Today guys, today we will be solving this problem. So page 46 of the book, problem 266. So the problem state that determine the resultant of the three forces acting on the dam shows in figure 266 and locate its intersection with the base B. For good design, these intersections should occur within the middle third of the base. That's it. So the book gives an answer of yes. So the meaning the resultant will occur within the middle third of the base AB. So I already draw the problem, so we can start solving it. So first we would like to so the problem asks us to solve the resultant and locate its and to locate it and prove that it is middle third of this base of the base. So first we will solve for the resultant. So the resultant is just summation of these forces. So we all know that the resultant is just equal to summation of forces x plus summation of forces y squared. So first we would like to sum up forces along x. So summation of forces x. So we have 10,000 here, positive, going to the right, then negative. So we would like to solve for the angle. So so if the angle here is 60, then obviously this is also 60. Then if we have this here 30, so then this is a perpendicular, right? $90 and 60, so basically the angle here is 30 degrees. So it is minus 6,000 cosine of 30 degrees. So x force, the summation of force along x is minus 6,000 cosine of 30. So we have 4803.84 or 85 pounds. Then summation forces y. So summation forces y, we have negative 24,000 minus 6,000 sine of 30. So equals to 27,000. So given the sign of these two forces, we can say that the direction of our resultant will, because the force is x, is going to the right, and the force y, or the summation of forces y is going down. So we can conclude that our resultant is down right. R. So now, using this formula, we can solve for the resultant. So the resultant is just equal to 85 squared plus negative 27 squared equals to 27,424.02 pounds. So this is our resultant. So we know that it is downright with a magnitude of 27,424 pounds, but yet we don't know where is the location of our resultant. So it is we are asked to the book asks us to here, let us read it again. So locate its intersection within base AB. So here, this is the base AB. So the resultant touches somewhere in the base, and it is middle third of the base AB. So somewhere here or somewhere here, third of the base. So we can draw the base here. This is A, B, and we can put the resultant here, which has a magnitude of 27,424 pounds. So this is point B, point A. So now we can sum up moment. So we would like also to find the theta here. So the theta is just equal to the summation of forces y over summation of forces x. So theta is just equal to summation of forces y, 27,000, 0, then 4803.85. So our angle is 4803.85 is 79.91 degrees. So this is our theta here. So now we know that if we sum up moment, this is the y component of the resultant, and this is the x component of the resultant. So fx frx, then fry. So this frx would become 0 because if we sum up moment at b, this frx will directly going towards that point. So the distance, also the distance is 0, so this is 0. So the force to be included is the force, the y component of the resultant. So this y component is just equal to 27.24.02 sine of the theta. So let me erase this. Oops. So sine of 79.91. So this is the force that we will include in our moment. So but first we would like also to find the moment in this point, right? So we already have the resultant, but we don't have the moment. So using these three forces, we cannot use the resultant because we don't know the distance of resultant to our point B, but we can use its components, which is these three forces. So summation moment at B is just equals to 6,000 minus, so 6,000 times 4 feet, then 24, so 24,000, extend it, so this is 7, so negative 24,000 times 11. Then we have 10,000 here, so 10,000 and the moment arm of 6, so it is a positive, plus 10,000 times 6. So our moment is times 4 minus 24,000, 11, and 10,000 times 6. So we have 22,000 negative 22. So this is feet. So negative sign means our rotation is counterclockwise, and also whatever is our distance, it is to the left of point B. So that is the meaning of having a negative moment. So having a negative moment will make our distance or the location of our resultant to the left of our moment center. So the formula is moment is equals to force times distance. So we already have the moment, that 22,000 at 22,800, and the force, which is the force. So we can now solve for the distance. The distance is moment over force, and 22,000. What is this? 228,000 over 27,000. 424.02 sine of 79.91. So the distance is so it is 8.44 feet. So this is our location, and it is to the left of point B. So remember that if our moment is negative, so our distance is to the left of our moment center, and in this problem we sum up moment at point B, so our distance is to the left of this point. So our resultant is somewhere maybe here, 9, maybe here. So this is the resultant of these three forces, the 27,424.02 pounds. So this is the resultant, which has the 9. So maybe the location may be somewhere here. So our answer is 8.44. So my estimation is wrong, maybe somewhere here. The location of our resultant. So because it is 8.44 to the left of B. So that is how you solve this problem. So again, this is our problem, and we are asked to locate the resultant and its location and direction also. So next, we have another problem here. So for the next tutorial, I might or I can solve this for you. So if you want to be updated in my next tutorial, so please subscribe and hit the bell button. So that's it, guys. So hope you learn something in my tutorial. So if you notice some error and mistake, please comment down below. So this is my whole solution. So for a short recap, so first we find the resultant. Then after finding the resultant, we prove that our resultant is down right. So here we find the angle here. Then because of the forces, the x component of resultant is going to be 0. So our force now to be included in our equation is the force is y, the y component of resultant. So then we find the moment, so here it is. Then we now use the moment formula to find the distance or the location of our resultant. So the moment, then the y component of the resultant. So 8 feet, then because our moment is negative, so this 8 feet is to the left of point B where we sum up our moment. So that's all, and thanks for watching.